and welcome to another jam-packed episode of CS Teaching Talks, where research meets reality. I'm your host, Dr. Emily Tomford. When I'm not reading papers here or discussing them with others, I teach computer science to pre-service teachers at Reach University. The paper we're discussing today is called Emerging Practices for Integrating Computer Science into Existing K-5 Subjects in the United States. The authors are Monica McGill, Lacey Thigpen, and Elena Mabie, and it was published in September 2023 in the Proceedings of the WiPSCE Conference on Primary and Secondary Computing Education Research. And with that, I am delighted to welcome this week's guests.
Hi, I'm Elizabeth Bacon. My pronouns are she or they, and I work at a computing and robotics education organization.
Hello, my name is Scott Moss. My pronouns are he and him, and I'm an instructional technology outreach coordinator at the Los Angeles County Office of Education.
Hello, I'm Morel Castaneda. My pronouns are she, her, and I'm a curriculum developer and translator for Coding Our Future.
I'm Paige Prescott. I'm Executive Director of Computer Science Alliance, a New Mexico-based education nonprofit, and my pronouns are she, her.
Hello, I'm Dr. Abigail Joseph. I'm an instructor for the Oracle Education Foundation, and my pronouns are she, her.
I'm Vicki Sedgwick. My pronouns are she, her, and I'm a recently retired elementary computer science teacher.
Hi, everybody. I'm Monica McGill. I'm president and CEO of the organization called csedresearch.org. I've been doing lots of research on K-12 computer science education, and some of it you're going to be reflecting on tonight.
What a great segue, Monica. Thank you. So our paper today is entitled Emerging Practices for Integrating Computer Science into Existing K-5 Subjects in the United States. And I am delighted to announce that we are being joined by one of the authors. So Monica, I'd love to give you first pass at this. Do you want to say something about where you're coming from and your intent with this paper and a little bit about your authors in the project?
Sure. So this is a project that was funded by code.org as they wanted to learn more about integrating computer science into K-5 for their curriculum offerings. So it was actually a deep dive, and this is only one piece of it. So we did a lit review, a systematic lit review. We did a survey, we did focus groups, and then we did expert interviews. And then this paper is just on the expert interviews. So folks who've actually been involved in curriculum development and or researchers, combination, some or both, who've had years of experience working on integrating computer science into K-5 and trying to understand what works and what doesn't work.
And I'd love to start it out with defining integration. So what does it mean to you in practice and, in theory, and are those different?
Well, I consider true integration to be where both content or multiple contents are moving along simultaneously, and they are both important for the outcomes and the student learning. And if you removed one of them, then the whole learning would disintegrate.
Yeah, I do agree with that. However, in practice, I don't think that's what's happening in most cases. I often see that one subject area, one content area is lesser than the other. It happens a lot in practicality. The non-tested area ends up just becoming subservient to the other. At least that's what I've seen in my experience with people who are trying to do this work.
Morel, I know you've been working with Coding Our Future and creating curriculum that is integrated from the start. Do you have your own kind of interpretation of what integration means or how it functions?
Yeah, this one's already I'm already thinking so much about it because I was like, oh, integration is when both subjects are running parallel within this hour that is allotted for it. But then I'm like, it really shouldn't be that way. It should also be like all subjects are integrated in some way. Like, oh, we learned about science and now we're doing storytelling, and it's kind of integrated as well. So like, how can teachers do that? Because those lessons were pre-planned to be integrated in that way, but that's just not a possibility to do so and to come up with
I think Morel makes a really good point that like all subjects should be integrated. There's no reason that we necessarily need to be learning about things in silos, and that one of the things, there were two things that really stuck out to me as the benefits of integration, or things that, you know, worked well with integration. And one was the like situating things within the context of authentic problems or authentic situations. And if you're doing that, I think it does lend itself to integration, because like authentic problems in the world are not just like a maths problem or a reading with multiple choice questions at the end. They're going to be integrated, which is why we have coding in the sciences, which is why, you know, the storytelling and Scratch go well together, all those things. So I think that was a really like that was a real benefit that I saw out of the paper that just worked really well. And it's really just because of the way that we've structured education that makes it more difficult. It's not by its nature integration is hard. It's just hard to do integration when you have your math block and your ELA block and your science block. And then for your science block, you're going to a different room with a different teacher. Well, now it's super difficult.
Teachers have to see the benefit, and students have to see the benefit of computer science beyond, hey, someday you could get a job as a programmer. I think by putting computer science in authentic context, it helps teachers and students see the value of it, because we're obviously immersed in computers and computer science every day, all the time. So I think it's important for students to see it in authentic context, and that you can use computer science, learn computer science, and the benefits of all that without doing it in order so that you could get a job at Google someday.
I was just going to connect that to earlier conversation Emily and I were having about preparing teachers to teach CS, and a lot of the authorization programs for CS credentialing come out of the computer science sphere because of the mandates that be, but shouldn't they be coming out of the education school? And so this paper is interesting in that I think there's a lot of it in there that is a great case for introducing this to faculty in the College of Education to really get them thinking about, oh, well, if I'm not teaching my teachers to do this, then how will they be effective at doing this thing?
What is the challenge? What is the problem that integration is trying to solve? And then what additional barriers or challenges does it bring in?
I feel like the integration, it's often mentioned as the solution for K-5, but it doesn't address the structural issues like that Elizabeth brought up, or that the comfort of teachers being able to do it. And but if it is done, it can be really like authentic to computer science, where it is pervasive across many disciplines, and give the students a sense of kind of the power of computer science and coding in a different way, rather than here's a sequence of things that you need to learn, like here's loops, here's algorithm. And integration tends to be a little bit more authentic, like just more experiential, more problem-based. And I think students can really learn. It just takes more time, right? So then there's all these structural issues that are not addressed in our current configuration of schools and how they're set up. So although it's mentioned, and like for New Mexico, it's in our state plan for K-8, and this is how we're going to do it. And it could be a way to get equity if all students are getting computer science in an integrated way, but it just doesn't, the manifestation of it is lacking. And I just see a light touch in terms of how computer science is integrated. It's more like I'm kind of thinking through a SAMR model. I don't know if ed tech, the substitution, augmentation, modification, and redefinition. I think I feel like it's all substitution. It's like, well, you could do a poster, or you could do a slide, or you could do a Scratch project, and so you're not really advancing the knowledge of, let's say, science or math or language arts with that. And so I think there's a lot of layers, but I would feel it's worthwhile to really study and to really solve this problem, because I think this is a beautiful place for education.
Yeah, I notice anything I've ever read on integration, one, it always focuses just on algorithms and programming. And that's only one of the 5 areas. So I think there's integration areas that we don't ever talk about. Data's an especially big one that can definitely be, I think, more easily integrated than algorithms and programming can into science and math, just because they're already doing a lot of those things. They're just not using computers to do them. So if now, especially at younger grades, they're not using the computer yet, but if we can introduce, here's how a computer could help you solve that at a bigger scale, right? Then you become why data is important and how to analyze it using a computer and all of that. So I think there's pieces we're missing.
I think that it's really echoing what we learned when we talked to folks as well, that, someone had mentioned that, one's always more dominant than the other. How do you get true integration, and what does that mean? Especially one of the subjects like literacy, right? That's being tested.
I noticed both of you just referenced the light touch. And I think that was something that I was reading as I was kind of listening to the summaries of the interviews and the quotes. Sequencing comes up a lot, loops come up a lot, but we know that our standards include way more than that. Like sequencing and loops are literally one standard. You're 2 total across K-5. I know, Vicki, you are deeply involved in the standards, CSTA. How did that feel to you?
So I think there's pieces we're missing. Programming's, I think, the easy lift where people go, oh, well, I can, like you mentioned, use it as a substitution for the poster that they used to do. Now they'll write a Scratch project instead. And I think that's where people tend to go. But I think there's so many other opportunities, and the impacts can be in so many places as well.
On the top of page 8 of the paper, there is a nice blue diagram where it has very succinctly laid out the trends and strategies for integration across 4 core subjects: ELA, math, science, and social studies. And I thought it might be cool if we could isolate each one of those and talk about our experience with each one. So a lot of people have made reference to ELA. The 2 tips in that box are to use games and other tools and reflect upon how language is used in English and in computing.
Well, I think that's the whole focus. Like, for example, in the Scratch Junior curriculum that was originally written in Tufts, it very much is focused that way as a language, and how computers use language and how we use language. So, and I think that's not a bad fit. And there's so much sequencing also in ELA. That's also a great fit, beginning, middle, end of stories, all of that kind of stuff. So I can see why that would have been a focus for sure.
Going out and getting that technical information from documentation, being able to read technical documents is standard, is a standard that we have for ELA. And in K-5, we do expect kids to present their work, and there are standards that we have around presentational speech. So those are just things that are maybe already integrated across all classes, but I think that it is nice to kind of point them out as great opportunities for us.
One quote stood out to me, or one section of the article says, language arts was mentioned several times by participants with emphasis on using integrated CS as a self-expression. And then it went on to talk about something that was different from what I understood from that. But I thought that in itself is so powerful. Like, if teachers are saying that literacy and CS truly integrated is a form of self-expression, there is self-expression with CS, and like that's what literacy is, right? Like storytelling, like this was my process, this was my experience, this is how I went about creating this is how I went about problem solving, the bugging it. Like, really, there's so much there. And if teachers were saying that, I feel like it would be so easy to integrate CS with storytelling and self-expression, because self-expression is so limitless.
I think one really big opportunity is understanding different points of view, and to be able to understand that you are not your user is a lot of the same standards we see at that level about, like, you are not the character. The narrator is not the character. So why do people have different points of view, and why? So that's a thing that I think we're with SEL, social emotional learning, it's just so important. So I think that's a really, really great place for us to dig into, that a lot of educators would be super excited about.
I'd like to continue us along a little diagram here and open it up to math. So the strategies that are listed are go heavy on computational thinking, use virtual manipulatives, focus on fractions, and enhance learning with other tools.
I feel like math is a challenging one because it's the tool that is being used dictates what kind of math can be done. And sometimes it's not at the right age level. Like XY coordinates comes up so often as like, well, we can do math with, but that's not at a younger grade level, but the tool has that capability. So it's like a bit of exposure, but it can be a little tricky with that.
One of my favorite things to do with kids is geometry, which isn't in the list, even though it was mentioned in the article. But and we did an amazing unit with our second graders last year, and Finch robots and drawing with the Finch robots and all of this stuff. And the kids themselves recognized that they were using their math concepts and what they learned in art about abstract artists to create this artwork that they created. So, I mean, it was amazing that the kids even got that that's what they were doing. And so I think there are opportunities, but I think you have to be particular in what you're choosing and how you're doing it, because there's also so many things that can be confusing, like variables, for example, since they are different from, and so that becomes a confusion point rather than helping to teach them the math concept, right? It now is confusing the math concept. So I think we have to be very intentional. And so I can see why it can be an area that teachers think they should be concentrating on, but have a difficult time actually doing anything that helps further the math curriculum while they're trying to teach the CS.
I think that also depends on grade level. I love quoting one of my students who said that they never cared about angles, the coordinate plane, and variables until they were using those things to make their game or their computer program. It was always just, doing it, to get a grade in math, and to apply those things in a meaningful context, I think is very powerful.
So let's complete our sequence with science and social studies. There's one tip for science: leverage cause and effect in science with conditional logic. And for social studies, it's incorporate cultural holidays into CS.
I think we're missing a lot in science, actually. Science is an awesome place just to, do simulations of things and play with those. And, I just think you're missing the boat on how CS is really used in science, And there's a lot of data analysis you could actually start doing in upper elementary in social studies as well.
So for science, there's a whole part of NGSS that's the engineering, technology, and application of science, which is basically the engineering design process, which is pretty similar to the software development process, especially when we bring in the idea of computing systems. So I think that's a place where we have a lot of opportunities to go into these science classrooms, because a lot of the science teachers, they're not happy with what they have on that. So I found that one kind of winning thing from integration, and I did this with the local middle school here, where I was talking to 7th grade science teachers, and it's just like, what part of your science year do you hate? And they were like, I won't call out the curriculum or the project, but they were like, this one thing. And so we said, okay, why don't we replace it with this other thing? And we were able to do that and incorporate a lot of the computing systems standards in there, some algorithmic standards. But was one that was basically a drop-in. It was not, there wasn't a scope and sequence for the computer science. It was definitely just like, here's some standards that we're going to drop in, because it was almost just a proof of concept. But the buy-in for the teachers was great, because number one, they didn't want to do that part of their curriculum anyway. They were happy to see it go. And number two, because it was computing, it brought in Perkins funding for CTE. So I found that that like helping science teachers incorporate the engineering standards, which are still relatively new, was a winner for buy-in, at least.
You know, we did a micro-credential for culturally responsive pedagogy in computer science, and they were supposed to come up with artifacts that, you know, brought in all these things. And overwhelmingly, the lessons were integration. And this was K-12, so it was pretty broad, but it was very much about integration and very much about like student choice. And also for the K-5, it ended up being very social studies oriented, because they were looking at historical figures, or were looking at sort of mapping and seeing things that could be moved along in the maps and understanding geography in that way. It was really interesting to see that. And so, you know, it speaks to the fact that I think teachers are inclined to do integration when given the opportunity to create something, but that, you know, there's constraints that they have in the reality of their day and week and school year that prevent the actual implementation.
Something you just said made me think about just wondering how this paper could be utilized to create a support system for teachers that are on that edge. They're starting to think about doing computer science in their classroom. How can we fuel support and then feed back those teachers into our system to fuel support and feed back more teachers into this system? I think that's what I got out of this paper, was that it had like a good scaffolding that could really be used in some type of teacher support program to get those catalyze those teachers that are ready to do it.
You can't just take a science, you know, let's say you have to teach science 8 hours a week, right? And you have it all structured and all of the topics in that 8 hours that you're supposed to teach. You can't just introduce computer science and expect it not to take more time, because it will take more time. So it's not going to, you know, some way or another, things have to be adjusted if we're actually going to bring it into K-5. I don't know how or what that looks like, but this, you know, a perception that, oh, we can just integrate it and therefore it will solve the time problem is not true.
If we ask teachers what they do and what they do well, can't we take those things and figure out how to integrate CS curriculum into those things? And so there was a mention of standards in here a few times, and all the standards are separate. And we know that teachers are teaching to standards. Is there not a way for the CS world to infiltrate the existing standards that all the schools are holding as Bible and be a nice complement with them and still teach to those standards? Because I think the fight is that CS is thought of as just another thing that I have to do in my long list of things. And I think we need to get administrators and the people to be to think about how we are really enveloping into what teachers already do really well and celebrate them for that.
I was actually kind of thinking like the opposite way of like, what's not going well? Let's disrupt that. But I hear what you're saying. I was just kind of coming at it from that different direction.
I think there's room for both. And I was just thinking, like, the thing that I just hear from teachers over and over again, and from being a teacher myself, is that Yeah, I could try to disrupt the system, but I don't have energy for that. But I'm all for disruption. So let's go,
Well,
Elizabeth.
yeah, I don't mean to. I just mean like the thing that you don't like doing. Let's not do that, and let's do this other thing.
Yeah.
That's all I meant. Yeah.
Yeah.
Tell me which of your lessons is not working, and let's do computer science in that first.
Yeah, let's mess with the one you don't like.
Yeah.
Yeah, there are lots of like integration strategies that I know and I've developed over the years that weren't even said in here. Like, I always think when we're going to do computer science in a math class, there are certain ways we can relate to math through computer science. One is teaching the computer how to do the algorithm we have just learned. Another one is along from that, making a checker to check my math work. Or you have them tell the story of their math problem or their process of doing the math. Or model, how the math of something works. Or the golden one, like the one that is the most compelling, is if they use the math concept they've just learned to make a part of a video game work. But that's the one with the biggest lift, right? Because you have to have the video game, it has to be relevant, you have to have the part, you have to know which part, you have to teach that part. And there's so many different ways of engaging with math and so many possibilities within each of these ones. I wish I'd seen that in the table. Because again, social studies, you can engage through maps, making an interactive map, timelines, right? Sorting time and having things go in a sequence. You can interact through, a journey or a navigation, a demographic thing, vocabulary, make a matching game, have make a meme of it that animates it, make a video that, or, an animation that would express or correct the difference between two terms, tell a story that describes to me how these words work. There's so many more opportunities for integration than were listed here.
I think they missed an opportunity to interrogate how CS is a creative discipline. And I'll explain that because as Emily was just spouting off all these different ways you could integrate, I was thinking she can do that because she has so much knowledge of all these different areas. And then I was thinking of the classroom teacher and how our education, and I know for me personally, sucked my creative life force tremendously. And I think there's an opportunity to go back and ask teachers, how are you creative? What sparks your creativity? How do you think about new problems to solve in your classroom? That's the basis of computer science. It's about the problem solving. And if teachers aren't using that muscle, then it's going to be very hard to get them to integrate something new. And maybe that's where we need to start, is connecting that idea of how are you creative, how are you imaginative, how are you dreaming, how are you visioning in your classroom, and connect that to the dreaming and envisioning of bringing in computer science as this tool that Emily so eloquently rattled off all these different ways it could be integrated so easily. But if teachers aren't using that muscle, then that's going to be a hard lift. The other part that I think they missed is asking more about the why, interrogating the why do computer science. I think that fundamentally for the teachers that I've been teaching has been the catalyst. And I hope the thing that keeps them wanting to figure it out more and more, even when it feels hard and challenging to come up with new ways, or they're hitting up against administration or whatever it is that's keeping computer science, them from doing computer science with their students. But going back to those whys, why is it even important for teachers to integrate computer science? That piece was not in this paper, and I think that's an important fundamental piece if we're going to take it and then try to get people to integrate. But why is it even important? Why is it important for our children to understand computer science? Yes, we're in a technology age, but
if we're talking about why do they need to know computer science within the context of integration, it's also why does a mathematician need to know computer science, and why does a computer scientist need to know math? Why does a historian need to know, like, and especially why does a computer scientist need to know history? I think that's something that we really need to make sure people get, is why do you need to understand the historical context of any technology that you create? So those, like, asking those questions of that authentic connection between the disciplines, I think is a really great source of the truly integrated stuff.
Well, we've come to the last 5 minutes of our hour. So I always like to ask, what are you going to take away? Do you have any conclusions, or do you have lingering questions?
So I take away that integration is hard, but it needs some special considerations, and that we need to really dig into understand what are we have some understanding of the teacher constraints and things like that, but are there others? Like, what would a PD and a support look like that would bring together all of this in the best practices? Because that's what promising practices, that's what you guys were looking for, right? And so, like, what are examples of these promising practices? And I have a feeling that it means that they've structured school differently, and that they have a different sort of mindset about education. And so how could we make it more pervasive across those schools that are more traditional in their styles? So it's a hard problem, but it's worth solving.
I totally agree with Paige. It's hard, but it's a problem definitely worth solving. And I wonder how some of us could help with that problem, what we could do, resources that might be created that could help with this problem. I don't know what they are right now, but it's got me thinking.
My takeaway, I think, is a focus on teacher buy-in. I think that's kind of a big first step that we need to achieve. So, make this as easy as possible, those first steps, so teachers don't reject it immediately. And somehow, I don't know the answer to this, get teachers more comfortable with teaching content they don't know, that they're not experts in. And that's always a big challenge. So that is part of getting that teacher buy-in that's so important.
I'm taking away that computer science is a creative endeavor that easily intersects with other subjects, disciplines, fields of study, and that if we ask ourselves enough why questions, we will find the answers to how to better integrate CS into the classroom.
So I don't know if this is going to be controversial, but I think what I'm really feeling from reading this is that computer science and computer science education, or the design of computer science education, is a lot more education and the design of education than it is computer science, meaning that the same approaches that we have to education are what we need to take to computer science education. That's where we need to draw our approaches, but that's also the challenges that we're going to have similar challenges. So when it comes to things like, what we feel would be great, co-design with teachers, we have the same challenges that that we would see from other places of, are we just going to pay them to do it? Will we put the resources in? So I think, when we talk about professional development, that's the best practice. It's the same challenge in education. When, how do we get teachers these resources? So I think that, this is it's a great paper to highlight that and, continue to take that away, but that it being computer science education doesn't necessarily mean that we have like a unique set of tools that are going to solve these same problems. We have the same barriers because we have this, it's operating in the same environment.
My takeaway is like more research projects, because I would like to do studies with just science teachers, right? And learn what their integration techniques are. So it's different when you have a study where you're trying to cover all this topic area, as opposed to go in and really find out what the kind of the experts are doing in those separate fields as a separate study each. And I think that would really shape things up as well. But there's hardly anything in the research right now about this. So that's why we're trying to get our work published from co.org, the whole lot of it, to show, oh, these are all these barriers, and now let's start working on them so we can get teachers more comfortable teaching, so that we can start growing and learning, because I think it'll look completely different in 4 years than it does now.
Well, that's all we have time for this week on the CS Teaching Talks podcast. I really enjoyed discussing this paper with people from all around the country. So thanks to Abigail Joseph, Paige Prescott, Scott Moss, Morel Castaneda, Vicki Sedgwick, Elizabeth Bacon, and our very own Monica McGill, as we were discussing emerging practices for integrating computer science into existing K-5 subjects in the United States by Monica McGill, Lacey Thigpen, and Aleda Mabie. If you would like to join us in any of our future discussions, you are welcome. You don't even have to have read the paper ahead of time. We will welcome you on Tuesdays at 5 p.m. Pacific or Fridays at 4 p.m. Pacific, and you can find all the information about our discussion group on our website, csedresearch.org. We're also excited to hear from you. Send us your comments, your insights, your paper recommendations. You can send that by email to podcast@csedresearch.org. The CS Teaching Talks podcast is presented by csedresearch.org and Reach University. Funding has been provided by the Association of Computing Machinery's Special Interest Group for Computer Science Education and Amazon Future Engineer. Thanks, everyone. See you next time.